In this video, we are solving a LeetCode task number 3190. Find the minimum operations to make all elements divisible by 3. We are given an integer array, nums, and we need to find the minimum number of operations to make all its elements divisible by 3. In one operation, we can either add 1 or subtract 1 from any element in nums. So for each element, we have some number of operations needed, and we need to add all of them and return the result. For example, if we have array 1, 2, 3, and 4, for number 1, it's not divisible by 3. And let's see how many operations we need to make it divisible by 3. If we add 1 to it, it becomes number 2, which is still not divisible by 3. And if we add 1 more time, it becomes 3, which is divisible by 3. So if we choose to apply add operation, we need to apply it twice, so we need 2 operations. But if we choose subtract 1 from it, so it becomes 0 and it becomes divisible by 3 in only one operation. So the minimum number of operations to make number 1 divisible by 3 is 1 operation. For number 2, if we apply add 1 to it, it becomes divisible by 3 in only one step. 3 is already divisible by 3, so we don't need any operations. And for number 4, if we subtract 1 from it, so it becomes number 3, which is divisible by 3. So we need one operation here. So we need one operation for number 1, one operation for number 2, 0 operations for number 3, and one operation for number 4, which is in total 3 operations. And it's our result. So let's look at the pseudocode before diving into the C# implementation. We need to calculate total number of operations starting from 0. And we need to go through each element in array to determine the number of operations needed for each. So how we calculate the total number of operations for one element? If element is already divisible by 3, we don't need any operations, so the current number of operations for our element is 0. But if our element is not divisible by 3, we can either have the remainder 1 or 2. We cannot have remainder 3 when dividing by 3 because it will mean that our element is already divisible by 3. So in case we have remainder 1, we need to subtract 1 from it once, so we need one operation. If the remainder is 2, like for element 2, we need to add 1 to it, and it will become divisible by 3 in only one operation. So it doesn't matter if the remainder is 1 or 2, we will need one operation. And we calculated number of operations needed for our current element, and we need to add it to the total number of operations. And inside this for each loop, we are calculating our total number of operations, and after the loop, we have it already prepared, and we just need to return the result. Now, let's transform this pseudocode into C#. The total number of operations will be an integer number. We are using for each loop to iterate through elements. Each element in nums is integer because it's an array of integers. We are declaring current operations integer as well. And we can create a Boolean variable is divisible to check if our element is divisible by 3, if the remainder is 0. And if it's divisible by 3, we don't need any operations. Otherwise, we need one operation, as explained. And we are increasing our result. And at the end, we are returning our result. Here, instead of this if-else branches, we can use ternary operator composed of questionnaire and column operators. And it's ternary because it's applied to 3 parameters: is divisible, boolean, condition, this number 0 in this case, and number 1. First operator is condition, is divisible, boolean condition, and if this condition is satisfied, we will apply this value. If not, we will apply this value. So in total, we have the same logic as using this if-else branch. In terms of some performance and so on, it doesn't matter which one we will use. If-else branches may be better to use when we have some complex statements and so on to be clearer what we are doing. But here, for some basic operations, it will be more readable if we are using a ternary operator instead of if-else branch. Now let's try to run and submit our code. Okay. Okay, our solution has been accepted, which means that all test cases passed successfully. So let us discuss the time and space complexity of this solution. First, time complexity. Here, it's a constant operation in terms of time complexity. Then we have this for each loop where we are iterating through all elements in nums. So if we say that n is the size of given input nums, we need to n iterations. So this will be linear time complexity, and this one is constant as well. Inside the for each loop, we have all constant operations in terms of time complexity. So in total, for each loop stays linear, and our solution has linear time complexity. For space complexity, we can ignore this input because we don't create it explicitly. This one is constant. Inside for each loop, these variables are constant as well and stays constant even though they are created inside the for each loop, because after each iteration they don't exist anymore. So in each moment we have only constant space complexity. This one doesn't have an impact to space complexity, so in total we have the constant space complexity. Now let's take a look at data structures, algorithms, and complexity we covered. We discussed integers and applied some basic operations on them. We are given array as input, and in each iteration we get each element. We implemented iterative brute force solution without any optimizations because it's not possible here. And we covered linear time complexity and constant space complexity.